We're going to have Michael Johansen talking about dust and NASA's dust mitigation strategies.
All right, thanks, Julie. So for those that don't know me, my name is Michael Johansen. I am the Technical Integration Manager in the Space Technology Mission Directorate that's responsible for the dust mitigation strategy. So you'll hear me use the word strategy as opposed to technologies, because technologies are just, of course, one piece of that overall strategy with operations and architecture considerations, of course, making up some of that overall NASA dust mitigation strategy. We can go to the next slide, please. So in the interest of time, I won't spend too much time here, but of course, we see Gene Cernan, Apollo 17 commander, in his debriefs, he says things like, probably the most difficult job of all the closeouts is trying to dust the suits, and the real-time transcripts will show just how much time and effort was spent in dusting. With a few minutes later, in his EVA closeout audio transcript saying, boy, I tell you, I ain't never going to do much dusting after I leave here ever. 3 minutes later after that saying, boy, you got dirty today. I think we're just going to have to live with it. Now, keep in mind, this is Apollo 17 EVA-3, so this is the last time that humans were on the surface of the moon. And even although those missions are fairly compressed, especially when we talk about the timescales that we're talking about here for next generation lunar exploration, they had some time to learn, and there was still lots to learn about how we handle a dusty lunar environment. So the agency has been hard at work making a number of investments in this area. We can go to the next slide, please. Seems like there may be a bit of a lag. There we go. So of course, we've established the LSII Lunar Surface Innovation Initiative. Lunar dust mitigation is a part of that, of course, and I think that most folks on the line are probably aware of this initiative. And if we go to the next slide, the way that universities and industry can, and other government agencies and a wide variety of other entities may participate in NASA's tech development and operational considerations in all of these areas is through the LSIC. We can move on to the LSIC chart, please. Thank you. So the LSII system integrator, of course, is APL. And so we've established a consortium where we're taking inputs from academia, government, nonprofit organizations, and industry to get some feedback on all of those technology areas. And you're probably aware of this as well, so we won't spend much time here, but if you are interested in participating in that, you can look up the Lunar Surface Innovation Consortium, and there are focus groups for each of those technology areas. Next slide, please. So to go along with what the agency needs, we've developed these capability areas essentially for dust mitigations. Of course, we have optical systems, things like viewports and camera lenses, solar panels. Under thermal surfaces, of course, thermal radiators, fabrics and mechanisms. Of course, another big area when we talk about things that failed or maybe didn't work as well as we expected in a lunar dusty environment in the past. Steels and soft goods, another one of those key areas. We're also going to be looking at things like gaseous filtration and lunar surface modification. So we haven't made a substantial investment in this technology area, especially compared to where we're going as an agency, and in like the last decade since we had the Constellation program, we made some investments there. But if you move on to the next slide, please. So under STMD's game-changing development, we have currently 6 tasks within a single project, where we're looking at some active technologies to demonstrate on potential CLPS landers like the electrodynamic dust shield, the patch plate materials compatibility assessment, where we're looking at materials and how regolith sticks to these materials. Under technology development, we're looking at how to better design dust tolerant mechanisms, using existing mechanisms and high TRL existing mechanisms as that technology that we're looking at protecting. Low dust, this sealing effort has a number of materials and active mitigation investigations as well. Under Dust Mitigation Best Practices Guide, this is that how-to guide. So, many of our stakeholders around the agency are really wondering, what is it that we already know about designing dust-tolerant mechanisms or protecting surfaces, for example. So this Dust Mitigation Best Practices Guide is something that is being developed out of STMD to support that need in the agency and, of course, with our partners as well. Under the Dusty Environments classification, this is a high-level guidance document where we are looking at defining certain classes of dusty environments and defining test standards for how we test in a coordinated manner. So, for example, one type of surface is being tested the same way as another type of surface if it is all if it is all the same or at least relevant. It's putting together this high-level guidance for the agency. Next slide, please. To go along with that, we've also made a substantial investment in SBIR this year. So under active and passive surfaces and dust tolerant mechanisms, you can see those selections that were made just recently, and also under lunar dust management. So here we're seeing things like the electrodynamic dust shield, but a very bendable variety of this, solar array coatings, and looking at dust tolerant joints, and a wide variety of things that you can read through later at your leisure. But we are making a pretty decent investment in SBIR dust mitigation technologies as well. Next slide, please. Under early stage innovations, this was a call that we released earlier this year. And I guess it was the end of April of this year. This is, of course, one way that we're bringing in university, a look at how universities might handle dust modeling. So we're looking at things like particle adhesion and cohesion, particle transport, and lunar dust particle characteristics, and how they affect things like evaluation of mitigation technologies. So that proposal period has closed. We're going through the review process now. We're expecting notification of those awards in October of 2020 with an award date in something like January of 2021. So that's one piece of how we're bringing universities into the fold for how we handle dust mitigation as an agency. But if you move on to the next slide, please. Another way that we can handle including universities for that technology piece, is through the NASA Big Idea Challenge. So this year, in fact, just released on July 22nd, so just a few days ago, NASA released this year's Big Idea Challenge, which is open to any U.S. universities that are affiliated with their state space grant consortium, with awards that typically fall into the 50 to 180K type of funding layout. And if you look at this call in a little more detail, you'll see that we are looking for a pretty wide variety of technologies and things like landing dust mitigation, spacesuit dust tolerance, of course, exterior dust cleanup, and cabin cleanup. So that almost end-to-end architecture, we want to see what the universities can do with technologies. And if you click on that link later, you'll be able to see this page here on the right-hand side in full detail. Next slide, please.
And we're at 1 minute.
Yep. And I've got one slide left, so perfect timing. So that, as I mentioned, that's one piece of NASA's dust mitigation strategy, is the technology piece that I demonstrated. But and those are just some of the investments that the agency is making. But here you can see that, for an integrated dust mitigation strategy, and there's more details for each one of these areas, but we have to look at things like surface operations and habitats and descent and ascent, even on-orbit assets, to look at correlations between what one system needs and what another system needs, but also the outputs from one become the inputs of another. So there's actually also a substantial investment being made in the area of an integrated dust mitigation strategy from an operations and architecture perspective. And we can certainly handle that in another time. But with that, it looks like I'm out of time. Thank you.